This question is from GATE 2017 Mechanical Engineering Paper Set 2, question number 51. Maximize z equal to 5x1 plus 3x2. Subjected to the constraints x1 plus 2x2 is less than or equal to 10, x1 minus x2 is less than or equal to 8, and x1 comma x2 is greater than or equal to 0. In the starting simplex tableau, x1 and x2 are non-basic variables and the value of z is 0. The value of z in the next simplex tableau is dash. Let's find out. So this is the objective function given and these are the constraints. And for starting we have to take x1 and x2 as non-basic variables and z to be 0. So we'll start with converting these inequalities into equations by adding slack variables. So let's consider x3 and x4 to be slack variables. So the first constraint becomes x1 plus 2x2 plus x3 is equal to 10 and x1 minus x2 plus x4 is equal to 8. Subjected to x1, x2, x3 and x4 all to be greater than or equal to 0. So they have already said that x1 and x2 we have to take as non-basic variables for the first simplex tableau. Therefore, first basic feasible solution will be putting x1 and x2 to be 0. We have 0 plus 2 times 0 plus x3 is equal to 10. This gives us x3 as 10 and from the second one we get x4 as 8. So this is our first basic feasible solution. Of course, when we write the objective function, the slack variables should not have any effect on the objective function. So 5x1 plus 3x2 plus coefficient of slack variables in objective function should be 0. So whatever is the value of slack function, objective function should not change by it. It will only change by the values of x1 and x2. Now let's form the simplex table. So we'll write the Cj row first. Cj row is nothing but the objective coefficient row. We have to write the coefficients of objective function. So x1 has the coefficient 5, x2 has coefficient 3. For x3 and x4 coefficients are 0 and 0. Then we write down the B column here or the right hand side of the equations. So for objective function, we don't have any right hand side. It's a value. Next, we write the constraint equations as it is. So x1 has the coefficient 1, x2 has the coefficient 2, x3 also has the coefficient 1 and x4 is not present in the first constraint. So the coefficient is 0. Similarly, we have for the second constraint 1, minus 1, 0 and 1. Right hand sides of these equations are 10 and 8 respectively. Now we need to decide which variable is going to enter and which variable is going to leave the simplex tableau. So to do that, we'll write the row Cj minus Zj. And of course, x3 and x4 are the slack variables we are going to write here. You have to take the coefficients of x3 and x4 in the objective function that are 0 and 0. So here we write down the row Cj minus Zj. Now we take the dot product over here of this column with this column and then find out Cj minus Zj. Zj being this dot product and Cj being the coefficient of each of the variables in the objective function. So x1, x2 are the non-basic variables which has the coefficients 5 and 3. So C1 for x1 is 5, C2 which is for x2 is 3, C3 which is for x3 is 0 and similarly C4 which is for x4 is 0. And Z1, Z2, Z3, Z4 are the corresponding values of these dot products which we take here now. When we take the dot product for the first x1 corresponding to x1, we get 1 into 0, 0 plus 1 into 0, 0 and 5 which is C1 minus Z1 which we got as 0 will be 5 itself. Similarly, C2 is 3 and Z2 we get as 2 into 0 plus minus 1 into 0, 3 minus 0 which is 3 again. Here we get 0 minus 0 and again we get 0 minus 0 as 0 itself. So the variable that will have maximum value of Cj minus Zj is going to enter, that is x1 is going to enter because it has the maximum value 5 among these 4. And in order to decide which variable x1 will replace, whether it's x3 or it's x4, we will have to calculate theta. One more factor which is nothing but b upon these coefficient values. So these coefficient values 1, 2, 1, 0 and then in the next row 1, minus 1, 0, 1 actually are denoted by aij. So this factor will decide which variable x1 will replace, because x1 is now going to become a basic variable, replacing one of the variables, one of the slack variables, either x3 or x4. So this will be decided upon the variable which will have minimum value of theta will be leaving. So theta is calculated as b upon aij. So we get 10 upon 1, which is 10 itself, while here we have 8 upon 1, which is 8. So the variable that it will replace is x4, because x4 has the minimum value 8 here. So we can write x4 leaves and x1 enters. Now we form the next iteration or the next tableau, simplex table method. So in the next table, x3 and x1 will be written as the basic variables. We write here x3, x1. Coefficient of x3 in z is 0. Coefficient of x1 in z is 5. So we'll write these accordingly. Now, what will be the elements in this row will be identified using the pivot row and the pivot element. Also, we need to have an identity matrix corresponding to the basic variables. Now our basic variables are x3 and x1. So corresponding to this, we should get an identity matrix. That means 0 and 1 at this position should be present. So the standard procedure for getting that identity matrix here is that we have to find out the pivot element and divide the complete row with the pivot element. Pivot row is nothing but the row corresponding to the leaving variable. So this is the pivot row. And pivot element will be this element, that is the intersection of this row and this first entering element variable. So 1 is the pivot element. We divide the second row with the pivot element. So 1 by 1 gives us 1 itself. Minus 1 by 1 will be minus 1. 0 by 1 will be 0 and 1 by 1 will be 0. They are simply the same numbers because we are dividing with 1. 8 by 1 will be 8 here. Now, we need to get a 0 at this position. In order to get this 0, we'll have to perform a row operation. The numbers that we have are 1 and 1. So simply if we do R1 as R1 minus R2, we will get 0 over here because 1 minus 1 gives us 0. Then it is 2 minus minus 1, which is 2 plus 1, which is 3. Then we have 1 minus 0, again 1, and 0 minus 1, we have minus 1 here. These coefficients we will write down as it is 5, 3, 0, 0. Also this last element we have to compute. This applies to the right hand side also. We have to perform this operation on this element too. So it is 10 minus 8, 2. Now we will compute Cj minus Zj in order to get the value of objective function Z. So Cj minus Zj using the same procedure that we followed earlier. So writing these coefficients of x1, x2, x3, x4 in the objective function as 5, 3, 0, 0 as it is. Now Cj minus Zj for the first term will be 5 minus 0 into 0 plus 1 into 5. So it is 5 minus 5, 0. Then we have 3 minus 3 into 0 plus minus 1 into 5. That is 3 minus minus 5, which is 8. Then we have 0 minus 1 into 0, 0 plus 5 into 0, 0. So we'll get 0 itself. And the last one will be 0 minus 1 into 0 is 0 plus 1 into 5 is 5. So 0 minus 5 is minus 5. Here doing the same thing, we have 2 into 0, 0 plus 8 into 5, 40. So we have our new set of solution. Value of x3 is 2, value of x1 is 8 and value of objective function is 40. The value which we're getting here is the value of the objective function. So in the second simplex table, we are getting the value of objective function as 40. Our answer is 40. Let's go back and fill in the answer. So the value of z in the next simplex tableau is 40. To learn more about this simplex table method, you can refer to the NPTEL video, Lecture 4, Linear Programming Solutions, Simplex Algorithm. This video is from the course Fundamentals of Operation Research. The course is by Professor G. Srinivasan. He is from Department of Management Studies of IIT Madras. I hope this solution will help you clear your doubt. Thank you.